Welcome to the deep dive. Today we're jumping into network health, basically how we keep everything digital running the way it should. You know those times, right? Your internet connection just feels flaky, or maybe it drops completely for a second. Super frustrating. We're going to look at how some really smart systems try to prevent that. We're digging into parts of a document called NetOpsVA, AI Network Anomaly Detection. It talks about something specific, interface flap detection. So our mission today: unpack how the system uses AI, artificial intelligence, to catch these tiny network hiccups. The idea is to spot them before they turn into those big outages that drive everyone crazy, getting ahead of the game.
Exactly. And what's really interesting about this NetOpsVA system is that it's not just about fixing things after they break. It's aiming for real-time visibility and even prediction. It focuses hard on those really frequent up and down changes on a network connection, what they call flaps.
Okay, let's unpack that term, interface flap. What exactly is it, and why is it bad for, network stability? Sounds a bit like a light switch being flicked.
That's actually a pretty good way to think about it, yeah. An interface flap is basically a network port, a connection going up, down, really fast. And why is that a problem? Well, every time it goes down, even for a moment, that's a potential drops packet, a lost bit of data. If it happens repeatedly, it's like a constant tremor. It makes the connection unreliable, can slow things down for everyone connected, or even cause wider issues as other parts of the network try to, compensate. So NetOpsVA monitors this. It watches for these rapid changes within a set time window using a threshold you can configure, and it keeps a history, a state log, to see if these patterns are happening over time.
Right, so that's the classic way, just counting the obvious on-offs.
Yeah.
Makes sense. But the document highlights AI-based anomaly detection. This sounds like the really cool part. How does AI take it a step further? What's it doing differently?
Yeah, this is where it gets smarter. It uses an AI technique, specifically something called isolation forest. It looks at rolling windows of data about the interface's state, so chunks of recent history. And instead of just counting flaps, the isolation forest is designed to mathematically isolate the truly unusual patterns. Think of it as spotting behaviors that are statistically weird, even if they don't cross the simple flap count threshold.
Huh. So it could find something subtle that looks okay at first glance, but the AI says, hang on, this pattern is odd.
Exactly. It's looking for those faint signals, the anomalies that might predict a future failure or developing problem.
Yeah.
This gives network teams proactive insights. They can investigate before users experience downtime.
Yeah.
It's about prevention.
Predictive, not just reactive. I like that. But thinking about constantly monitoring and running AI analysis, that sounds resource intensive. Wouldn't it slow things down? How does it manage that?
That's a really important consideration, yeah. And it seems they designed NetOpsVA with efficiency baked in. The document mentions things like max memory history and maxed history. Basically, it limits how much data it keeps right there in active memory for the AI to chew on, and how much it stores longer term in a database. It's smart about managing its footprint.
So it doesn't become the problem itself.
Right. It even cleans up data for interfaces that it hasn't seen in a while. This keeps the whole monitoring process scalable, even for really large networks.
Okay, so for someone actually using this, say a network engineer listening right now,
Yeah.
what does it look like? The document mentions a dashboard view. How does that help?
Yeah, the dashboard aims to simplify all this data. You typically see a couple of key things. There'd be a table for classic flaps showing the device IP, interface, the raw flap count, the straightforward stuff.
Okay.
But then crucially, another table for AI predicted anomalies. This is where the magic happens. It shows what the AI suspects is coming. Maybe a predicted state likely to fail soon, along with notes on why it thinks that.
Ah, so it gives context.
Exactly. And usually there are summary cards too, like total flap seen, total AI anomalies detected, maybe a quick list of the most critical interfaces the AI is worried about.
Yeah.
Makes it easy to see where to focus first.
Got it. So bringing it all together, what's the big picture impact? How does this change network management overall?
Well, connecting the dots, a system like NetOpsVA really pushes network management towards being proactive.
Yeah.
It significantly cuts down on manual troubleshooting, the constant firefighting, because the AI basically flags potential issues for you, often before they cause real trouble.
Freeing up engineers to be more strategic.
Precisely. Plus, as we said, it's designed to be efficient with memory and database use, which is key for performance. and it's built to integrate. It uses standard things like SNMP, which most network gear, like Cisco devices, already supports. So getting it working shouldn't be a massive headache.
This look at NetOpsVA really paints a clear picture. We're moving away from just fixing things when they break towards systems that can actually anticipate and prevent problems. That feels like a major step.
It absolutely is. And it brings up a really interesting question to think about, maybe for you listening. As AI gets embedded deeper into our infrastructure, this digital foundation we all rely on, how is our whole idea of reliability going to change? And what new kinds of challenges might pop up because these systems are becoming so intelligent? Are there risks we haven't considered?
Definitely something to mull over. Thanks for joining us on this deep dive into the world of AI spotting network troubles.